Okay, so this is the demonstration of the path planning AI project that I was doing using uh, ROS simulation of a drone. So I'll just start it. So basically, the algorithms are based on 3D VHF, and which is basically uh, creating Bezier curves to to solve the path and to explore the world and basically uh, learn the world. So, yeah, uh, so Arviz, and obviously for the simulation, I'm using Gazebo with ROS. Okay, so so this is the world which we will be dealing with. So yeah, so you can see that this is the drone that will be using, and this is a world which is already downloaded, so I take no credits for that. Uh, yeah, so basically it doesn't know the whole world right now, the drone. So I'll just explain. So basically these two vectors actually, they'll basically represent the the drone's movement and the leading point. So basically, it will draw. Uh, so the base. So it will have 2 points basically. So and it draws a parametric curve through these 2 points, which is actually Bezier curve. So yeah, so that's how it starts its plan, and as soon as it goes near buildings, obstacles, or whatever, it starts to learn the obstacles, and that's how it will uh, basically avoid all the obstacles and also reach the destination. uh, so yeah, and I don't know if this is the fastest way, but yeah, this is kind of the idea. So yeah, so I'll just demonstrate once. So I'll just arm this. So I'll put this in off-board mode, and I'll arm it. Okay, so as you can see, the vectors are rising, so which means the drone is also actually rising. So yeah, so you can see the drone taking off, and it'll hover at a place. Obviously, there are drifts because it's a realistic simulation, so there are uh, all things to account for, like wind and uh, viscosity in air, and many small things that actually matter. So yeah, so as this is hovering now, I'll show you how we can actually plan the path. So as you can see, even when it gets armed, it will create this curve from the origin to the final point here. So now as I so basically these blocks represent the effective world of the drone for the drone. So basically this is what will matter for the drone right now. So it keeps on changing because obviously it has small disturbances, and the drone is actually moving continuously. So that's why these are the basic effective blocks. Now it doesn't know the whole world, as you can see. So it just sees the front blocks and some of the side blocks that will matter. Now as I set a goal, it will basically reach that point, and it will first here. So we'll first create a curve. So I'll just put a point right, uh, maybe let's say here. Yeah. So you can see this is the Bezier curve that it makes, and as soon as that happens, this leading arrow and this the drone's vector will create these curves, and it will edit it as the obstacles come nearby. So yeah, so if you can see, this building is coming near it, but I guess the goal is not behind the building. So it will reach it. It will not collide with anything, and it will edit the curve as soon as it reaches an obstacle. So so as you can see, the world is also expanding for the drone, and that's why it's also learning the whole world. So yeah, so this is how the curve will change continuously. Now it's basically reached this point right there. So now you can see that these blocks are also coming into the effective world for the drone. I'll also demonstrate it another time to expand the world again. So this is the world for now. I'll take it a bit behind. So I'll take it somewhere there. So it will create the curve from tangent from this to that. So yeah. Yeah, it's basically auto rotating, that's why it's difficult to see. I'll just show you what's happening in the real situation. Yeah, that's the drone actually. It's yeah, here it is. It's going towards this house, and it will basically learn this house right there. If you can see this, I rotate. Yeah, so it's empty right now, but it'll learn these blocks right here. So yeah, the world is expanding for the drone. Yeah, so it's learning that there's a house right there, and it's basically skipping it so that it doesn't collide with it, and it will reach the goal. There are small Gaussian disturbances that need to be taken account for, uh, because obviously this is not really a very real case, but yeah, it's a kind of comparable to reality. And yeah, so one more thing I wanted to show is this. Yeah, so in the terminal, basically, it will print the risk and the smoothness of the curve, and this cost actually uh, determines this cost is actually telling us how much battery voltage has to be dropped to take that longer path or bigger curve. So that's the cost, and distance is of course the curve length, and yeah. So yeah, so if the point is inside a building or something, so that will basically be indicated like printed by path is bad, because the the point exists inside an object which is obviously not penetrable. So yeah, so that's so it will plan a new path so that it can just be the nearest to that given goal point. So that's how it actually works. I'll Yeah, so it's basically reached a more farther point. Here it's drifting here, so you can see the world is actually expanding for it. So yeah, so that's the effective world for it now. So if it traverses through the whole world for about 2-3 rounds, it will basically learn the whole world. So that's it. Thank you.